Hi and welcome to this new video. This time I would like to show you what happens under the hood when you call the collect method on top of an RDD. But remember before doing that the collect method is quite expensive because it brings all the data from all the executors to the driver and it materializes the data immediately. That's the reason why you should use it only when the data which is processed on the executors will fit to the driver's memory. And currently I found that this method is sometimes used in Apache Spark internals. For example, when we'll try to show you that just now, when Apache Spark will list the files to process from a glob expression. So it was, let me find the file index. Yes, and there were something like refresh, which calls list the files, and inside you will find that we have another method which is called bulk list the files, that if there are much more files than this threshold, will execute a Spark job for all the input files, which here are exploded. So if you define some wildcard expression in the input, this input expression will be first exploded. So the code will figure out what are the files, the exact files to read, and later for every file or for every subdirectory, it will call these map partitions and map functions and execute it as a Spark job with the collect method. So initially I was thinking that because of this distributed character of this operation, the operation will be non-deterministic, meaning that it will return the resolved outputs in different order every time. However, if you check the collect implementation, you will see that it's not true, because every time Spark will return the data in the order of input partitions. And I will show you that just now with my sample code, where as you can see, I'm doing slightly the same thing. I have 11 input partitions that I will parallelize in memory. I will do some map partitions operations exactly like before, and later I will do the map and add some non-deterministic character, meaning that for these three numbers, this map function will sleep for 2 seconds, and obviously it will terminate at the end of the processing. And at the end I will collect it and print all the results in 2 different ways, just to show you that it's always printed in the same order. So let me run the code in the debug mode and see what happens. So you can see that this run job method is the one which is called when you invoke the collect on the RDD. And what is interesting here is that, as you can see, that we create an array with the capacity of the number of input partitions, and later this funct is our data processing function, so it will be our map function. And whenever a result is available here, we will put it to this array. So globally it means it's the place where the results are materialized on the driver. So this function is executed on executors, but this operation is made on the driver. So the driver asks executor to return the results, and it will put them into the place corresponding to the given input partition. And that's the reason why in the results you will always find the result of collect in the order of input partitions. So let me, okay, as you can see, we introduced some randomness in the processing, because you can see that the input is not processed in order, but at the end we will find, can even see here that we are not collecting the output in order. But despite that, at the end, you can see that we always have the same output. As well for this for each print as for this collected make string call. So the real reason for that is this small snippet, putting the executor's results to the correct place in the results array, meaning that of course the order of execution and any noise in executors will not be important for the final output. And if you want to discover more details on this collect method, I wrote a short blog post which is linked in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.